Hey, we're gonna be putting a few things together. We're gonna talk about the Pythagorean theorem or Pythagorean theorem, which requires a right triangle. If you have a right triangle, we're gonna state that the square of the hypotenuse, so basically if you make a square here, is equal to the square of this leg plus the square of this other leg. And we are also gonna be starting to name ratios between sides of a right triangle. And it's fairly simple. It's just a way of uh, putting names to certain ratios. So if you were to divide the opposite side by the hypotenuse, if you divide those two, we're going to call that the sine. And why is it an opposite? Because if you talk about theta, which side is right in front of theta or opposite to theta? So that is this side right here. And the hypotenuse is the longest side or the one in front of the 90-degree angle. And we call the adjacent the side that we have left. Now, you can also put a name to dividing the adjacent side by the hypotenuse or dividing the opposite but the adjacent, or you can also do it in the opposite direction. So if you divide, those are reciprocal. If you divide the hypotenuse by the opposite, we call it cosecant. If you divide the hypotenuse by the adjacent, we call it secant. And if we divide the adjacent by the opposite, we're going to call it cotangent. So sine, cosine, and tangent have their own reciprocal ratios. And now let's put that together in the following example. So let's say we have the hypotenuse as 29 because it's right in front of the 90-degree angle and it's going to be the longest side. Now we're going to start with this right here. So sine of theta. So we're talking about dividing the opposite by the hypotenuse. That's why we call it, or the name that we have for sine is whenever we divide the opposite by the hypotenuse. Which one is going to be the opposite? Well, based on the fact that this is theta and the side that is in front of it or opposite to theta is this side, we're going to call it the opposite and making this side the adjacent. But first, we need to figure out what the opposite side is. So let's call this side x and let's call this side y, which we're about to find. And well, we know that this is the h or hypotenuse. So hypotenuse square or the square of the hypotenuse is going to be equal to 20 squared plus y squared. And I forgot to replace the h, so we're going to get 29 squared is equal to 20 squared plus y squared. We're going to have 841 is equal to 400 plus y squared. And now it's just about solving for y. So 841 minus 400 is equal to y squared. 441 is y squared. And y would be the square root of 441 or 21. So now that we have this side as 21, it's just about putting the ratios together. Cosine is the adjacent over the hypotenuse. Tangent is the division of the opposite over adjacent. And then we have the reciprocal ratios, hypotenuse over the opposite side, then hypotenuse over the adjacent, and the adjacent over the opposite. And once we have the values, it's just about putting them together. 21 over 29, then 20 over 29, 21 over 20, and the reciprocals, you're going to notice that if sine is 21 over 29, cosecant will be 29 over 21, then 29 over 20 for cosine, and finally 20 over 21. Now, we're going to do something slightly different here. Since we want to find sine, still the opposite over hypotenuse, but based on beta, the position of angle beta. So which side is right in front of beta is right here, making it the opposite, and now turning this side into the adjacent and this one into the opposite side. Hypotenuse will always be the hypotenuse. So if we want to find still the opposite over the hypotenuse, 20 over 29. So it's just the division of two sides based on the position of an angle. Now this is going to be 21 over 29, still adjacent over hypotenuse, but now the adjacent is right here. And tangent is still opposite over adjacent. So 20 over 21. Cosecant will still be the reciprocal of sine. So 29 over 20. Cosine and secant. So 29 over 21. And 21 over 20. And that's pretty much how you can put those concepts together.